Hello and welcome to this episode of the Industrial Engineering Notebook. Today's topic is job shop clustering. No, that's not a 5, it is an S. So a job shop is a kind of manufacturing system. I did a separate video on that you can go check out. Job shops can become really complicated really fast because you have a lot of very different machines in your factory and you can make a lot of different kinds of products. So it can get very complicated, and we want a way to simplify. We want to know, are there ways that we can group the machines? Maybe that means putting them together, or if the machines are really simple, they're more like operations like drilling and then sawing. Maybe you just saw right after you drill every single time and make it one machine, quote unquote. And then for the products, do we need to look at these 2 items as separate products? Could we just group them together? Or these 5 items as separate products? Wouldn't it be easier if we could just group them together and we could make a much simpler map of our factory and do much better analysis? So we're going to say we have 5 machines and 6 different products. Let's look at it. Okay, so we have 5 machines and 6 products. And what I'm going to do here is I'm going to put a 1 if that product needs to go through that machine. So like we'll kind of make some columns here. If the product needs to go through a machine, we'll put a 1. If it doesn't, we'll put a 0. And here are our 1s and 0s. You can tell that each product kind of has its own needs. So product 3, it just needs machine 4. That's all it cares about. And then you got other products like product 6, which need most of them except for machine 2. And some just kind of jump around a little bit. You might be wondering why we need to simplify this. If we can express it in a simple little table, why would we want to simplify it? And I'll draw a little diagram of what would be happening in this job shop to help motivate the need for some job shop clustering. So we have our 5 machines, and I kind of just put them in a circular fashion here, so they're all kind of next to each other. And we have our 6 different products, each represented by these different lines. And then based on this matrix, I'm just going to kind of put these lines in here so we can get an overhead view of what would be happening in this job shop. And you can check my work here if you want, but the point is this gets really complicated. We only have a handful of machines and a handful of products, but already we can see a lot of kind of intercrossing paths. Machine 4 here, that's just for product 3. That was the only machine that it needed, so I kind of just put this line out here. But this is what we're looking at from just this table. So how can we group these machines and group these products to make a much simpler layout? So now we're going to get into the algorithm of how to cluster the machines and the products. There are equations and algorithm steps that go with this, but honestly, this is much easier to learn if we just go through an example of how it's done, and then it'll kind of make sense. First thing you got to do, come over here and start writing out powers of 2. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4th power, and I'm just going to simplify that and write what those actually equal. And these are going to be the weights that we apply to each of these columns. So for column 1, we're going to do 1 times 1 plus 1 times 4 plus 1 times 8, and then we're going to add all of those up. So 1 times 1 is 1, plus 4 plus 8 would be 13. And then same thing for product 2, except we're going to multiply this column by this column. So it would be 2 plus 8 plus 16, which would give us 26. Okay, now we have a weight for each column. And what we want to do is we want to reorganize the columns so that it goes in ascending order. So we would want product number 4 to come up here, and then it looks like product number 6 is the heaviest, so that's already in the back, which is good. So let me just reorganize these. So here are rearranged columns, and notice that I didn't just change the labels, I actually moved the whole column, so now it would be in ascending order based on the weights that we just calculated. So we did powers of 2, we calculated some weights, and then we reorganized the columns. And now what we're going to do is we're going to put some weights on the rows. So first step, again, powers of 2, and I'm just going to write what these actually equal to make our lives easier. Okay, now we can get some weights for our rows, just like we did for our columns before. So for machine 1, we would have 1 plus 4 plus 8 plus 32, which would give us 45. And then machine 2, same way, so we'd have 1 plus 16, which would give us 17, and so on. And now we want our rows to go in ascending order. So we put our weights on each row and we want to reorganize the whole row. So it looks like machine 2 would have to bump up to the top, and then machine 5 is already on the bottom, so that's good. Go ahead and reorganize those rows. And I'm going to leave the columns alone. I'm going to keep them in the same order that they are. All right, so this matrix is starting to get a little bit jumbled, but we're going to keep going with the process. We got our powers of 2. Notice that we switched back to getting weights for our columns here. And the weights would look like this. And we see that the columns are already in ascending order, so we don't have to do any rearrangement. And this is our stop condition. This is how we know that we're done. And you're probably looking at this and you're like, I don't get it. What did we actually do? How does this have anything to do with clustering machines or whatever? And let me point out the pattern to you. The first thing I noticed is we got 2 boxes of 1s here, and these are clusters. So machine 1 and 3 together, products 1 and 5 together, machines 4 and 5 together, products 2 and 6 together, and this kind of just leaves this up here as its own little cluster. So this algorithm kind of just solves the matrix almost like a Rubik's Cube in a way, where you just kind of weight things until you push everything, or all the 1s at least, to this diagonal here, and then you get your clusters. And let's redraw our diagram so we can see what the factory would look like now. So we have machine 1 and 3 together, and we'd have machine 4 and 5 together, and machine 2 over here. And then our products are clustered 2 now, so we have product 1 and product 5. And we'll say that one's a straight line, and it'll just kind of go through the other 2 here. And then putting those products flowing between each of these machine clusters. We can tell that this is way, way easier to look at than what we had before. If you remember from before, we had all these crossing lines and different products, and it was just hard to look at. It's really hard to get a handle of what's actually going on here. After making some groups just based on what machines work with what products, get a layout that's much easier to look like. And practically, combining machines, this might mean putting them physically right next to each other, or like I said, it might just be that drilling and sawing operation. So you just saw right after you drill every time, and then when you get a different kind of product, the operator knows, okay, don't saw after this product, just drill this product. Or another product comes through and they know, just drill it, don't saw it. As a result, we way simplify the flow, make a factory that's much easier to manage. If you liked this video, please hit the like button. I'll dot that I. If you want to see more of these videos, you should hit the subscribe button. I recommend it. And if you have questions, I know you have questions, put it in the comments. I will try to answer.